Yeah, so that is it. Feels pretty strange to be introduced by yourself, but well, welcome. I'm really happy to be here in Vilnius. It's my first time as a speaker here. I've already did Riga and Tallinn, so all Baltic states are covered. So as I've said, I'm working for not so small software company called Tog. We're about 100 developers. We're based in Warsaw, and the organizers wanted me to remind you that there is possibility to ask questions which I hopefully be ready to answer at the end of the talk. Okay, so that's more or less enough about me. Now let's talk about our customers. You see, based company, we work for biggest Polish enterprises. Most of them are mobile operators. So let's have a look what interesting data, what interesting use cases can we find in mobile operator market. So the data themselves are pretty interesting. I'll tell about numbers in Poland. So it's like biggest Polish telco operators has like about 20 million customers. And what data do they have? Of course, when you make a phone call, when you send SMS, there are certain events going through the network and through core systems. There are billing events, how much will the call actually cost, although recently it's mostly zero. And there are a lot of data about network usage. And let's not forget about localization, because not only Google and Facebook spy on you, also your mobile operator knows where you are. So how much data do we have for SMS, billing events? It's more or less like in Poland, it's like 3,500 events per second. During the day, of course, during the night or during Christmas is more or less. And for network usage and localization, there are different kinds of streams. Some of them are not so large, like 3 or 4,000 events per second, but some of them are really fine-grained. In fact, your phone is connecting to your mobile operator even to connect and say, okay, I'm here near this BTS, or base transmitter stations, and those streams are pretty large. They are like up to 100,000 events per second. So what can we do with those data? What people in telcos do with those data? We'll focus on actually two domains, two use cases. And the first one is marketing, right? We have marketing guys constantly thinking how to increase the revenue, how to send you more and more SMSs, like going, hey, we have this new iPhone, come to our point of sales and we'll give you coffee. Right? So what do they want to do? Well, they want to find interesting event. For example, you are near point of sales and we want to sell you this new iPhone, or you're heading to the, for example, Russian border, you're going out of European Union, so we want to send you a message, hey, go buy this roaming packet because otherwise you'll pay much more. Or they found out that you've called their another mobile operator, and they want to prevent you from leaving the company. So they want to find interesting event. They want to find that you are the right customer. For example, you pay your bills regularly, you have good enough packets and stuff like that. And then they want to act immediately, because you will leave country, you'll go past the point of sales and so on. So these are the three objectives that they want to achieve. And the second use case is fraud detection. Fraudsters are pretty intelligent people, and they constantly come up with new ideas. Some of them are actually pretty simple, like for example, premium usage frauds, when they set up some kind of more or less fake accounts and they call Tuvalu or Bermudas or something like that. And that's kind of loss for operator, because in the end they won't pay their bills. Or there are many use cases when they want to send SMS spam, well, kind of illegally. So for example, when phone operator detects that somebody calls 1,000, 2,000 distinct numbers in the course of half an hour, and they have kind of like normal non-limited plan, then probably it's a fraud and they want to block it. And also so more elaborate frauds like SIM cloning, when you take one SIM card, you do some technical mumbo jumbo, and you end up with few cards that can be used concurrently. And also even more elaborate stuff like SIM box termination fraud, when you set up illegally your own voice over IP operator. So again, the revenue assurance guys has to detect those frauds immediately and then block accounts, send some kind of alerts and so on. Now the operations that they're using to do that on these streams of data are pretty simple. For example, it's filtering from this gigantic stream of events that they want to filter out only few of them. They want to enrich them with various kinds of data, starting from customer profile and ending up with kind of scoring with machine learning models and so on. And especially for frauds, they also want to do some more elaborate stateful stuff like aggregations. We want to compute distinct numbers that this particular phone made in the course of, I don't know, 2 or 3 hours, or what is the cumulative amount of money that they will spend. Or for example, how fast did this phone move in time, so to prevent SIM cloning fraud. Now the interesting thing is that, well, telco operators are not so kind of young enterprises. They last for like, at least in Poland, for 15, 20 years, and they do this kind of stuff actually, and they do it in billing system. And most of the billing systems that come, they are usually like 15 or 20 years old. They do filtering, they can send some basic SMS stuff with informations like do this or do that, and they can also detect some basic frauds. They can compute simple credit limits and so on. But the problem is that the billing system is the core system of the company, and nobody wants to mess with it without reason, right? So even if there are some rules to do some action in the billing systems, they are changed pretty infrequently because, hey, it's core system. We don't want to let, for example, analysts touch that, because if it breaks, then everything breaks. On the other hand, analysts have access to various analytical tool warehouses and so on, and they can do queries, analysis, more or less statistical data and stuff like that. But the data appear in those tools with certain lag. Once upon a time, it was like a day or two. Now it's hours, but still the lag is considerable. And also, those tools are not kind of really production ready if you want to do things like, well, blocking accounts, sending SMSs, right? They are not so reliable. They have lesser SLAs and so on. So the question and the challenge that we wanted to solve is to let analysts or marketing guys, revenue assurance teams, to use the tool that will help them to be as fast and that will be as easy for them to use as, well, their normal warehouse analytical tools. Right now, how do we try to solve it? Well, now there will come the slide with, well, I would say generic big data architecture nowadays, right? So first we have data ingestion, we have data processing, then we have some kind of actions or outputs, and some enrichment, right? Yeah, you can take a photo, it will fit any purpose, right? And in this talk, I will concentrate about how to make this data processing stuff easy. But first, I'll have to mention that to make this work, you have to also, I would say, make your homework and first prepare your data accordingly, because more often than not in various systems of mobile operators, this data is in such various formats, is full of errors. Nobody knows what format of your phone number is. It can have 9 digits, 11 digits, some special characters in front of that. So we have to really be sure to normalize and filter out your data before you handle them to the analyst. And I know it sounds obvious, but it's not always the point. It's not always the case, and sometimes when the data that the analysts got, they are kind of full of trash, their work is so hard that it just doesn't make any sense. And on the other hand, you also have to make sure that the actions that you want to take, for example, blocking accounts, sending SMSs, they are also kind of developed, deployed properly, right? because analysts don't want to handle questions like technical deduplication, like handling errors, like for example replying in case of errors and so on. So firstly, we have to make good kind of APIs, interfaces to do all these actions so that they can be safely used by the analyst. Okay, and in the center, we have kind of more or less standard stuff. I won't talk about Kafka because it's kind of backbone of more or less every data integration nowadays. But the second important part in our case was Apache Flink, which is not as standard as Kafka, but its tracking and attention is on the rise. So why did we choose Apache Flink? Well, it was like 2 or 3 years ago, and then we virtually had no other options because now there are more tools like that, like Kafka Streams, Vespa, Spark Streaming, of course. But at that time, the choice was really limited. So we've chosen Flink, and we still think it's a very good choice because of the very low latency that Flink provides. So we can react to all those events in kind of less than a second. It has pretty rich and friendly API for handling state, Windows. The state API Flink is really rich and lets you handle state up to gigabytes without really realizing that. And also it has good semantics, really elaborate stuff that lets you be sure that your data is processed only once, that you don't drop messages, and you are safe in terms of resilience, high availability, and so on. Right, so we've installed all of our data. The data is ingested. We have our actions ready. So now we go to the analysis and say, okay, now you go and write your processes. And then they'll ask you, okay, but how? And we'll tell them, okay, so this is very friendly DSL. It's in a language called Scala. Well, we can also write in Java and recently even in Python. And you can have a look at that and you understand. You understand, right? And then the analyst said, because for the developers like us, or like me, I don't know about you, this is kind of very readable code. It's normal Scala code that's just deployed somewhere in distributed cluster. But for the analysts, it's kind of not so easy, because they are more or less, I would say, semi-technical people. They know the tools of the trade. They know Excel, SQL. They know some kind of worksheet or workbooks, notebooks nowadays. But they don't want to code in Scala and to, well, use the tool chain of the developers. That is SBT, Maven, version controls, and stuff like that. Although sooner or later they will have to learn that. So we have to figure out how to enable them to configure Flink jobs without actually writing Scala code. So our journey was more or less like that. We started with kind of proof of concept with Apache Flink. We hard-coded the first processes, and results were stellar. Performance was good. Business values delivered. So the project was approved, and then the question came, okay, so the processes are hard-coded. What do we do with them now if you want to change them? And our first thought was, okay, we'll prepare some configurations. You can configure the limits and so on. And the client said, well, it will work, but maybe we can do better, because we have to have kind of better possibilities of changing different things, different stuff, different conditions. And when we felt, okay, so in the configuration you can write some simple filtering or aggregating expression. It's written in some simple language called Scala. You'll master that. You won't have any problems with that. And they're saying, oh, okay, we can try, but it turned out to be not so easy as we and they thought. So in the end, we came to the idea, okay, we have to build graphical user interface, and because we had to make some fun out of that, we decided to make it open source, and our client kind of generously agreed. And this is how the tool I'm going to show you was born. And is Nussknacker. I know it's kind of weird logo. I know it's kind of weird name, but in the end, you won't forget about it, about just like all the other big data frameworks that you see, and they have logo like that look like nothing. And it's called Nussknacker because in the logo of Flink there's a squirrel, and for harder nuts you need Nussknacker. And if you Google up Nussknacker, real German Nussknacker, you'll see something more or less like that. Okay, so that was about the logo and the tool, and the goal that we try to achieve is to let the analysts fulfill whole kind of development lifecycle. So first they came up with some idea in in either warehouse, notebooks and so on. They'll mess up a bit with the data, and then we want them to encode the idea in kind of more like production ready tool. And then we want them to test it, first in kind of sandbox environment, then do some integration testing, and in the end, we want them to be kind of brave enough to push the button, deploy the stuff in production, and gather data for like a few days, see what happens, and repeat the cycle, right? This iterative cycle. So the question is how to do it. And when we started our project, we figured out that we need to have some kind of base ideas, base visions that we want to keep up with. So the first one, these base assumptions. So the first one is that the whole tool, the expressions, should be made accessible for semi-technical people who know SQL access and stuff like that. We know that real marketing people won't know how to use that, but there are enough analysts to make this whole concept viable. And second, we want to make it easy to facilitate their work in terms of testing, experimentation, because they are really creative. They have a lot of imagination, so we want to let them, well, do various things with that. And the third important assumption is that we will still need some code, kind of normal code written by normal developers and so on, right? We don't have the assumption that it will be zero code solution and everything can be clicked by the analysts, because we think that this is kind of a curve that compares completeness of your solution, how I would say Turing complete everything is, with the difficulty of use, right? That somewhere it ends up, this curve ends up rising exponentially, and we want to stop somewhere here, right? It's not like with NiFi where you can configure anything, but it's more like development tool than tool that's accessible for analysts, right? So at some point we want to stop and say, okay, this can't be done with our tool. For example, elaborate error handling, elaborate data ingestion and stuff like that. This should be done somewhere different, in some different place, right? And this is the effect that we've got. So this is kind of basic process, simple process. When first we have a stream of calls, then we do parallel processing. We filter out, we get the client data, we filter out premium calls, and export for some further analysis. And if we aggregate the amount of calls, or for example, how much the client will be charged, and we figure out that it will exceed some threshold, we'll send some alerts, we can block account and so on. So now it's kind of like basic tool to draw block programming or handling graphs. But the interesting thing is where do these building blocks come from? And of course they come from a toolbox, because from where's, and we have two kinds of building blocks. The first one is kind of generic building block, like filtering, aggregation, stuff like that. In all of our deployments to various customers, they use more or less the same stuff for filtering, aggregation, and things like that, declaring some variables, switches, and splits. And now the thing that you want to do when we configure a filter is, of course, you have to enter some filter expression, and for that we decided in the beginning to use something pretty simple called Spring Expression Language, because we are Java Scala developers at heart. And it turned out it's kind of good decision, because it's simple enough so we can analyze it and do some basic code completion in our tool, which is very helpful. And also we can analyze it and detect various problems with that. For example, here is a typo. We can detect, for example, some type coercion problems, so that you want to compare string to doubles and so on. And what's even more interesting for us was that the Spring Expression Language was performant enough. In fact, this is the language that's main kind of use is for configuration of Java applications. And we execute those expressions like, I would say, 200,000 or 300,000 times per second. And surprisingly, it's performant enough. It has some kind of bytecode generation and stuff like that. Okay, so this is for this basic elements, basic tools. Now let's go to more complex, more elaborate, and well, kind of more specific elements. Like for example, for each of our customers, we have to prepare to integrate with their own messaging system, their own tools for blocking client accounts, and so on and so forth. And this is not generic. This is not part of the tool. This is something that you have to develop in your model, right? Because the vision, how you deploy, how you design, deploy our tool, and then design processes, is that first you have to prepare the model for client, where you have data model integrations and stuff like that, the configuration, where is your Kafka cluster, where is your SMS gateway, and so on. And then the analyst will produce in these graphical tools, well, essentially JSON files depicting how the process will work, and everything is put into the Flink cluster and it works, right? So now we'll talk just a few minutes about how do we prepare this model and how do we make it work for our customers. And as I've said, the elements of the model is first the data. What fields do we have? Where do the data come from? Where can we put the data, either for analysis or alerting and stuff like that? And also, how do we define where do data for enrichment comes from? It can be various client profiles, like based on Redis or stuff like that, but also enrichment can mean, for example, model scoring, and also some various custom transformation, like more complex segregation. We'll talk about it in a minute. And this is more or less how the developers will write their integrations for well, their use, right? So this is kind of normal Scala code. You can also write it in Java. And here this param name annotation is just a mapping of parameters in user interface to our normal code, right? So here we define an element that has one parameter, customer ID, and then you can go to database, you can go to Redis cluster, you can go wherever you want and produce the data that you want to handle. So the first and foremost use case for that code kind of enriches is enrichment with client profile, for example, from Redis, to be quick, or to sending data somewhere, right? For example, sending SMSs, blocking accounts, setting some custom components, and so on and so forth. And as I've said, this is the part that has to be handled on normal development basis, right? To handle exceptions and stuff like that. And we can also use this kind of abstraction to go to more elaborate stuff, like for example model serving, starting with simple case where you put your model in with Python or R to some kind of container, and then we enrich just by REST API. Or you can also try to do some more, I would say, more efficient model serving using PFA or PMML, and then of course you have to integrate that with our tool, but all those elements can be also extracted from kind of generic metadata like Swagger or external model repo. So they will appear in the toolbox automatically. And when we come to models, we also have to think about, well, more advanced features that Flink provides, like Windows, state, and other Flink goodies. And for that, we decided not to go not to let users use full Flink API because they won't understand that, they'll mess with it, and things will break, right? Instead, we have some predefined aggregations and some checkboxes to do some custom job configurations if they really need. And for these custom aggregations, the idea is again the same. We have some parameter mapping, and then we have normal Flink code that creates aggregations just like developers want. So for kind of basic users, we can have simple aggregate solution, which underneath can use pretty complex algorithms. For example, this is really simple to use, but underneath it uses hyperlog algorithm to do approximate set cardinality solutions, which is very useful for frauds. And for more advanced users who can prepare, well, more advanced aggregations that are more powerful but a bit more kind of difficult to configure. Okay, so our analysts came up with the idea. They prepared the process, handle it to the developers to deliver that in next spring. So they want to test it. And we have two notions of tests. So first one is kind of sandbox testing. This is how kind of production-ready flow looks. Input data, ingestion, enrichment, and outputs. And for first sandbox testing, we let the user prepare their own data, test data in file, and then we mock out input, we mock out output, but still we use production client data, enrichment, and so on, right? So that they don't have to mock it out. And then we let user see how the data behave, how many data is filtered, and so on. And then he can drill inside and see what were the results of expression, the results of variables, and that will let him detect most of kind of basic errors, like for example, the filter that doesn't work and so on. But of course, that's not enough. And after the while, they will have to do integration testing. But before that, let's look at one more idea that's kind of enabled by Kafka, because in fact users don't have to prepare the test data themselves. They can generate the data because we can look at the input stream in Kafka and, for example, say, okay, give us last 10 messages or last 100 messages, and voila, the data is here. It's kind of production ready. You can play around with it a bit. But after this sandbox testing, there comes a time when a user wants to do more kind of integration testing to see how this process behaves for like 2 or 3 days before it's ready to go into production. And for that, again, the architecture based on Kafka lets us do it pretty easily. So this is our production environment, and then we have a clone, a copy of this environment called kind of, well, analytical environment, which is also more or less like production ready, but smaller. And then we replicate the input data to the smaller environment. And we also replicate all those enrichments, client profiles, models, and so on. And we let the user deploy the job here. Of course, no real SMSs is sent, no accounts are blocked, but still they can analyze how this process, how this model performs, right? And after the while, they'll click migrate to production button, they deploy it, and everyone is happy because the operations will take care of the rest, right? Well, they will, of course, but we also want business users to be able to control what is really happening, right? Because this is how the reality looks like. We have like, I don't know, 70 processes deployed on Flink cluster. We have up to 150 or to 200,000 events per second. And sometimes the processes can get pretty large. I wouldn't be able to come up with such idea, but our users are. So how do we control that? Of course, we have detailed monitoring for us as kind of development team, but we also want to let users see how their jobs are behaving. And for each job, there's kind of dedicated Grafana dashboard, which is kind of easy to use because Grafana has this nice notion of templates and so on. And this has some basic metrics, both technical, if the stream process is lagging or not, and also more kind of business-like. For example, how many events are filtered out here and there, right? So connected with kind of with dumping the process data to kind of data lake or warehouse. This combines with this kind of real-time monitoring gives the user a sense of control, right? So they can see how this model is performing. This Grafana gives some kind of holistic view, and after that they can drill down, for example, in Elasticsearch or Kibana to see what's really happening. And if the user makes some mistake, like here, for example, they chosen the wrong aggregation type, and instead of doing this hyperlog solutions with which is computed in kind of constant space, they try to aggregate it in more detailed way. You can see that the performance is dropped instantly, and then after the user fixes that, again he can see that the work is again everything is processed as it should be normally, right? So this is the kind of basic life cycle of the process of the job that we want to cover. And of course, as with all open source projects, and not only open source projects, it's kind of still a work in progress. We have a lot of more features that we want to add. One of them is better handling of joins. For example, both unions of different types of strings and joins of, for example, event stream with additional stream of, for example, user updates. This is well handled in Flink, but to do it in our graphical user interface is not so trivial. We wanted to also to be able for the users to use our tool not only for streaming jobs, but also for kind of more batch oriented campaigns, for example, marketing campaigns, because these are the same users and usually they want the same tool. And also we want to add some more features to visualize both in terms of testing and seeing how the job performs in production. And of course, because we still a lot of work to do on the documentation. So that's more or less what I wanted to show you. That's more or less what I wanted to talk. So the things that I want you to remember is first that when we try to deploy and design such things as a solution, it's good to think about the whole process, not only process design, but also how to test it, how to deploy it in production, how to make it work so that the user, the analysts, won't be kind of both afraid and too reckless to push the production button, and that they can gather good feedback instantly, or at least in a short time, and adjust their work. The second thing is as always, Pareto principle. We believe that most of the stuff, like 80%, can be done by analysis with this or that UI, but 20% of the stuff, this is important stuff, and we cannot get rid of developers that easily, and the rest should be done really with all the rigor of software development. Yeah, I know what you're thinking about the rigor of software development, but this is true, right? And the tool that we are trying to create is somewhere in the middle, right? On the left, we have some kind of ad hoc tools for analytic data warehouse visualization, like SAS, SQL stuff. And on the right side, we have some kind of more like business support system, production ready, all the rigor of continuous delivery, deployment, writing code in Scala, and so on. And we to try to be somewhere, to take some middle ground where we can have, well, maybe I'll say both of worlds. And if you want to try it out and have a look, then please do. It's kind of everything is on GitHub. We have some case studies about that. And that's all from me. Thank you for coming. If you have any questions, that I'll be really happy to answer that, and I hope you'll enjoy the conference.